What's up? I'm Vin, and today I'm going through the Algebra 1 regions from January 2023, and I'm going through parts 2, 3, and 4. So let's get started. For question 25, we're graphing the function g of x. To get a nice graph, we're going to press y equals, and we're going to press second x squared to get a square root, and then we're going to type in x plus 3. And now from here, if we press graph, we get a rough idea of what this is going to look like. But to get full precision here, we're going to press second graph to pull up a table. And you really just care about the values of x that give you actual y values here. The errors just mean that when you plug in these x values to the function, you're going to get a negative under the square root, which would actually give you an imaginary number. So that we wouldn't actually be able to graph in the real number system here. So what we do is we scroll, and the only values that I'm going to actually put in our table are the ones that give us positive, like integer whole number y values here, because these values here like 1.414 or so on, these are all irrational numbers, so you're not going to be able to graph these nicely. So I'm just going to copy down part of the table here. So we have x, and then we have g of x here, and the first value of x that gave us a nice y value was -3, gave us a y value of 0, and then we have -2, 1, and then we have 1, 2, and 6, 3. Now just know you can do this without a calculator. Like if you plug in -3 here, -3 plus 3 is 0, and the square root of 0 is 0. If you plug in -2, you're going to get the square root of 1. Plug in 1, you'll get the square root of 4 is 2. And if you plug in 6, you're going to get the square root of 9 is 3. And now we just plot these points. So once you get everything plotted here, you just want to make sure that you're going to connect it with this same shape that we saw on the calculator a moment ago. And after we connect these 4 points here, I'm just going to draw an arrow at the end to indicate that this will go on forever. So take a second to read through question 26. So there's a bunch of 6th graders that are voting on the location of their class trip, and here are the results. So we have what the boys vote for and what the girls vote for, but what we need to do is determine to the nearest percent the percentage of girls who voted for splashdown. So the language here is very particular, that we're looking for the percentage of just girls who voted for splashdown, which means that we're only going to be focusing on this row here, the row which tells us how many girls voted for each of these locations for the trip. So what we want to consider here is we want to consider how many girls are there in total. So we could just go back to the main screen here and add this up. We're going to have 39 plus 46, and then we're going to add 37 here. And this is going to tell us how many girls voted in these 6th grade classes. So I always like to write the totals off to the side here. So we have 122 girls in total. So what we're calculating here to the nearest percent is the percentage of girls that voted for splashdown would be, we're going to look at the part here. So 46 of the girls voted for splashdown out of the total. So this represents the total number of girls. So we're taking how many girls voted for splashdown out of the total number of girls. A very dangerous trap here would be to consider the total number of students. But remember, they're asking us the percentage of just girls. So that's why we're only considering the total number of girls. So now we just type that in, 46 divided by 122. And then we're going to take this decimal here. And when you want to convert a decimal like this to a percent, if you know how to just do this in your head, I just imagine the decimal place moves 2 to the right. We have 37.7, which is closer to 38%. Otherwise, you take your fraction and then you multiply it by 100 to convert it to a percent. So we would have 37.7%, which rounds to 38%. So our final answer here we're going to record is 38%. So for question 27, we are no longer in the multiple choice, so we actually have to show the algebra to solve for x. So we're going to take this inequality over here. So we have -2/3 x plus 6 is greater than -12. And for this, I would just start by subtracting 6 on both sides. So inequalities behave almost like equations, except for this part coming up. So we're going to have -2/3 x is greater than -18. And now to get rid of this coefficient of -2/3, what we're going to do is we're going to divide both sides by -2/3. But there's a very important rule to know, that anytime you multiply or divide both sides of an inequality by negative, the inequality changes direction. So this is going to cancel, and we're going to have x is now less than instead of greater than. And then a negative divided by a negative is positive. And if I want to simplify this, I could do keep, change, flip. So I'm going to keep the stuff on top of the fraction. I'm going to change the operation to multiplication, and I'm going to flip the thing on bottom. And Now this we could just use a calculator for, or we could just say 18 divided by 2 is 9, and 9 times 3 is 27. So this is going to give us x is less than 27. Question 28, we want to determine the common difference of the arithmetic sequence in which the first term is 3 and the fourth term is 15. So there's a few ways we could do this. And if you know the formula can be helpful here, that we have a sub n equals the first term plus n minus 1 times the common difference like this. And then what we have here is we're looking at the case where n is equal to 4. And if we have n is equal to 4, that tells us a sub 4 would be equal to a1 plus, and then we would have 4 minus 1. So we have 4 minus 1 times the common difference is d here. And now a sub 4, they told us, is 15. So this would be equal to the first term 3 plus 4 minus 1 is 3 times d. And now to solve, we could just go like this. We just subtract 3 on both sides. And we're going to have 12 equals 3d. And dividing both sides by 3 is going to give us here that d is equal to 4. So that's our common difference. Question 29, we have a and b here, and we want to explain why a plus b is irrational. So for this one, I would investigate first. And the square root of 363 could be broken down as the square root of 121 times the square root of 3, which is 11 square root 3. And this is definitely irrational because we have 11 times an irrational number. And I know square root 3 is irrational because this is not a perfect square. So right away, I don't actually have to write this in my explanation. This is just more for instructional purposes, but this is not a perfect square. So the square root of a non-perfect square is irrational. So I could say here that this number here is irrational. And now if we look at the next number, square root of 27, the square root of 27 simplifies to square root 9 times square root 3, which is 3 square root of 3. And this number here is also irrational for the same reason. So now we're ready to explain why a plus b is irrational, because when you add two irrational numbers together, the sum of two irrational numbers is irrational. Now for the next part of this, we want to explain why a times b is irrational. And here we could say a times b is equal to, and notice we already simplified that a was equal to 11 radical 3, and we're going to multiply that by 3 radical 3. And when we work this out, 11 times 3 is going to give us 33, and square root 3 times square root 3 is going to give us 3, and 33 times 3 is equal to 99. So this product is rational because our product works out to a whole number, and all whole numbers are rational. Now, just as a quick side note, if you didn't feel comfortable doing all of this math by hand, just know for this part here, because it is an explanation question, you can do the majority of the work here right in the calculator. So the square root of 363 times the square root of 27 will simplify simply to 99, and we don't actually have to show all this simplification here. But I did want to show how to simplify radicals just in case that shows up on a future Regents. Question 30, we're going to use the quadratic formula to solve this quadratic equation for x, rounding to the nearest hundredth. So the quadratic formula is in the back of the Regents on the reference page. Here is the quadratic formula. And these values here for a, b, and c are all on the quadratic equation here. So in general, we have ax squared plus bx plus c is equal to 0. So a is our coefficient of x squared. And if there's no number written there, the invisible number is 1. And b is our coefficient of x, and in this case, our b value is negative. We have a coefficient of negative 4. And our c value at the end is 1. So now we just plug in. We have x equals negative b is negative 4, plus or minus the square root of, and we have negative 4 squared minus 4 times a times c, all over 2a. Now, just to point out here, before we plug this into the calculator, the most common mistake is actually this piece right here, is that when students type this into the calculator, they don't put parentheses around the negative 4, and the calculator gives them something different. Now, before we type this in, we could clean this up a little bit. We could call this x equals 4 plus or minus the square root of, and let's say here we don't actually know how to simplify this, but this would be 16 minus 4 is 12. So I'll just pretend that I don't know how to simplify that by hand, and I'm going to leave the rest the same here, but that leading term here, negative 4, I'll just switch to positive 4. And then 2 times 1 on bottom is going to give us 2. Now, when you're typing this in, my advice to stay accurate, press alpha y equals enter if you have one of these TIs here, and you're going to press 4 and plus or minus. So we actually have to find both solutions. So we'll do the plus solution first. And we have the square root of, and remember the -4 squared, make sure you put parentheses around -4. Otherwise the calculator will give you something different and you will get it wrong. So you have -4 times A times C. And look, we know that 4 times 1 is going to be 4, but let's pretend, I don't know, it's the actual test and we're anxious and we just want to double check that 4 times 1 is equal to 4. So we could write this in exactly as we see it. So here's our first solution. To the nearest hundredth is going to be 3.73. And then our second solution, we could retype everything with a minus in front, or we just go up to it and press enter. And then we just replace the plus with a minus, press enter, and here's our second solution. So now let's just write out our two solutions. We have x equals 3.73 if we round our first answer to the nearest hundredth. And then our second answer, if we round to the nearest hundredth, we have a 7, so we have to round up to x equals 0.27. So here are our two solutions to that quadratic equation. Question 31, we have to factor completely. And anytime I hear that phrase, factor completely, two things come to mind. First, I want to find the GCF. Usually these start with finding a greatest common factor. And then the second thing, which is probably the most important one, because it's the most common mistake, is that there is usually more than one step. So there is usually more than one step. And I'm bringing this up because from grading regions, I noticed that a common mistake is that students do just one thing and then they don't factor it anymore. Factor completely means keep factoring until you can't factor it anymore. So here, if we find the GCF as x, we're going to be left with 4x squared because we're doing 4x to the third over x. And then 49x over x is going to leave us with minus 49. And now if we were to stop here, we wouldn't get the full credit. We have to use this concept that when you have something squared minus something else squared, this factors to a plus b times a minus b. So we have a difference of two squares factoring. So when I look at that, I just think here, well, if I were to look for my first a term here, what would be the square root of 4x squared? I would have an a value of 2x and I would have a b value of 7. And you could even see here, if I do a squared, I would get 4x squared. And if I do b squared, 7 squared would give us 49. So this is now going to factor to x times, we would have 2x plus 7 times 2x minus 7. So this is our expression factored completely. Now for question 32, we have to graph a piecewise function. And these could be very tricky to deal with. A common mistake with these is that students just graph both functions simultaneously, like it's a system of equations. But this is not a system of equations. So what I would do for this is first I would graph the absolute value function. So we have the absolute value of x plus 3, and we're going to look at x values here, but the only x values we're going to use are x values that are less than -2. Now I'm going to write -2 here, but notice this is x is strictly less than -2. So I'm going to write the phrase here open because I am going to plug in -2 to see what happens if I do plug it in. But when I graph it, I'm going to leave it as an open circle. So if I plug in -2 for x, I'm going to have -2 plus 3 is 1, and the absolute value of 1 is 1. And now if we plug in something less than -2, like let's say -3, -4, -5, this is going to give us an idea of the rest of our curve. So if we plug in -3, that's going to give us 0 on the inside, and the absolute value of 0 is 0. If you plug in -4 plus 3 is -1, and the absolute value of -1 is +1. And if we plug in -5, this is going to work out to 2 here. Just know that we could get a graph of absolute value x plus 3. And if I just think about what this graph looks like, it's the absolute value function, and the vertex is at -3, 0 like this. But remember, with piecewise functions, it's almost like part of the graph is being erased. Everything less than -2 is what we're going to be graphing here. So everything to the right of -2 kind of just gets erased out here. So that's kind of what I imagine in my head before I actually start graphing this. So now I'm going to plot these points. So now that I have these points graphed, notice that I left -2, 1 open here. So now I'm going to connect this, but I'm going to connect it with the V shape. But remember, with piecewise functions here, you're not going to be graphing the entire absolute value here. We're going to stop when the inequality, or where the inequality tells us to stop. So we're stopping here at this transition point of -2. So now for the second half of our graph, we're looking at the curve x squared plus 1. And now we're between -2 and 2. So now we're going to start at -2, and this time we're going to be closed at -2 for this graph. And we're going to stop at x equals +2. So I'd go to -1, 0, 1, 2 like this. So right away I'm thinking x squared plus 1, if I think about the entire graph, looks like this. But remember, I'm not going to be graphing the entire graph. I'm going to be starting it at x equals -2, and I'm going to be stopping it at x equals +2. So that's going to, once again, kind of erase part of the graph here. So it's just going to be part of this parabola like this. So now if we go ahead and look at these points, if I were to plug in -2 here, and I could use the calculator for this, but this I could just do in my head. -2 squared plus 1 is going to give us 4 plus 1 is 5. If I plug in -1, -1 squared plus 1 is 2. Plug in 0, you get 1. Plug in x equals 1, you're going to get a y value of 2. And you plug in x equals 2, you're going to get a y value of 5. And now I'm going to plot these points. Now another thing here, notice the graph does end at x equals 2. So don't put an arrow at the end of this graph here. So this, we're just going to be connecting this piece as is. So now we're in the part 3s. The questions are worth 4 credits. Question 33, we have Anessa is studying the population of a town, and the graph below shows the population over 50 years. And first we need to state the entire interval during which the population remains constant. So if you notice here, the y-axis represents the population in thousands. So if we want to look for where the population remains constant, we want to look for where the population is not changing. So if we look over here at this section, notice that the population is flattening out here at 10,000 people. So this is between year 20 and year 30. So if we're going to mark our interval here, we could write this a few different ways, but we could say between 20 and 30 is when the population remains constant. For the second part here, we want to state the maximum population of the town over the 50-year period. And notice the y-axis tells us the population. So we're looking for what part of the graph is the y value the highest. And we look over here, this is where the y value is the highest. And what is the y value there? The y value is 10. But be careful, the population itself can't be 10. That's not a very impressive maximum population. Notice the population is in thousands. So the answer would be 10,000. That would be our maximum population. For the third part of this question, we're going to determine the average rate of change from year 30 to year 40. So go over to the graph. This is the point 30, 10. And then this point down here is 40, 4. So the average rate of change is really just the slope between those 2 points. So here we're just going to find the slope. It's going to be 10 minus 4 divided by, so we're doing the difference of the y values over the difference of the x values. Now just notice here that the graph is decreasing. So the average rate of change should come out negative. So if you mess up the order here and this comes out positive, the graph kind of allows you to check your work as you go. But one thing I like to write here is the units, that the y value units along the population axis is in thousands. So on top, I'm going to write thousands. And this is not part of your grade, so you don't have to write this, but I like to write it because it helps me explain what it means later. So we have thousands, and on bottom, this unit for 30 minus 40, the x-axis is in years. So thousands per year. And if we work this out here, this is going to give us 6 divided by -10. And I'll just do that on the side. We have 6 divided by -10, and that's going to give us -0.6. So this is going to give us -0.6 thousands per year. Now, this here is, I guess, a little bit sloppy, because if we're talking about the change in population, it'd be nice to talk about it in terms of how many people. So what I would think about at this part here is that if I had -0.6 thousands, I'm really just multiplying this by 1,000, and that would equal -600. And this actually makes more sense for when we actually explain it later, that I could rewrite this in terms of -600 people are leaving per year. Okay, so what that actually means is that, I don't know, maybe people don't like this town anymore, but people are starting to move out. So now that we did the analysis of the units in the third part here, we could write our explanation that the average rate of change means that the population is decreasing at an average rate of 600 people per year. Now, one thing to note here, just to be safe, I like to include the interval in my explanation that this is happening between year 30 and year 40. Question 34 is mostly calculator work. The first thing we want to do is get this data in the calculator. So we're going to go over to Stat, and we're going to press Edit here, and then we're going to clear out the table and replace it with these values. Now this question is asking for a linear regression. So now we could press stat. We're going to go over to calculate here. And under calculate, we have linear regression as option 4. So we're going to press 4, and then we're just going to keep pressing enter like this until we get all the data that we need. Now, one thing you'll notice here is that we're missing our correlation coefficient. So what we could do here is we could go to the catalog, and under the catalog, we want to turn the diagnostic on. So we could press alpha D here like this. So I'm just going to press alpha D, and it's going to bring us over to the letter D, and we could switch diagnostic on over here like this. Now just know you could also press mode and go over to the diagnostic and switch it on as well. So you see stats diagnostics, we could toggle it between off and on. But now when we go to stats and calculate the linear regression at option 4 and press calculate, notice now that we get our R value, which we're going to need for the later part. Now we're rounding all values to the nearest hundredth, and what I would do here just to be safe here is I would write down the general form of the linear equation here, and I would define our A value is negative 2.81, and our B value is going to be 97.55. So now when we write our equation, we're going to have y equals negative 2.81x, and then we have plus 97.55. Now the reason why I like to write all this stuff over here and not just the final answer is that if you make a small mistake but you define each piece, you can get yourself some partial credit. For the second part here, we just have to state the correlation coefficient, and we're going to round to the nearest hundredth. So that's the R value over here. We're going to have R equals negative 0.97. For the last part of this question, what I'm thinking of is that our R value is between negative 1 and 1. And the closer we are to negative 1 or positive 1, if we're close to either of these numbers, that would be a strong correlation. But if we're close to negative 1, that's a strong negative correlation. If we're close to positive 1, that's a strong positive correlation. So all we have to do is state what the correlation coefficient indicates about the linear fit of the data. And this is a strong correlation because it's close to negative 1. Now, one important thing to note is that correlation does not imply causation, but the data does suggest that the more classes you miss, the lower your final exam score is going to be. So the Regents likes to send out these little subliminal messages to all of you. So just try to attend as many classes as you can. Take a second to read through question 35. So we have a fence going around a rectangular garden. So what I'm imagining here is a rectangle, and we have the length and we have the width of the rectangle. And the fencing is representing the perimeter of the garden. And we're told that the length of the fence is 5 less than 3 times the width. So that we could express as 3w minus 5. It's important to know that you're going to write the minus 5 at the end because it's 5 feet less than 3 times the width w. So this is how we want to express it. And we're told here that the amount of fencing used was 90 feet. We'll just know in general that the perimeter of a rectangle, if you were to add up L plus W, that's going to give you 2L plus 2W. But we're told here the amount of fencing used was 90 feet. So this represents the perimeter. So we could say the perimeter is 90, and that is equal to 2 times L plus 2 times W. And now for the first part of this question, we just have to write a system of equations, or we could write an equation using one variable that models this situation. So what we have here represents our system. And if we solve this system, we'll be able to find the exact dimensions. So let's go ahead and get the dimensions now. So I would solve this system by substitution, since this already says L equals. So we would have 90 equals 2 times, and I'll leave a space. Instead of L plus 2W like this, I'm going to replace L with 3W minus 5. And what this did is it turns this equation here on bottom into a single variable equation that we could solve. So now we're just going to distribute the 2, and we're going to have 6w minus 10 plus 2w, and we're going to have 90 on the left side. So now from here we could just combine like terms. 6w plus 2w is going to give us 8w. We have minus 10. We have 90 on this side. So now just add 10 to both sides, and you're going to have 100 equals 8w. And then from here we're just going to divide both sides by 8. And if we do 100 divided by 8, this tells us that w is going to be equal to 12.5. And now from here, we want to solve for the length. So what we could do is we could plug this into the first equation that already says L equals. So we're going to have L equals 3 times W, which is 12.5. And then we're subtracting 5 from this. So when we work this out, 3 times 12.5 minus 5 is going to give us 32.5 feet. So our dimensions, I'll write our final answer formally. We have a width of 12.5 feet, and we have the length is equal to 32.5 feet. So here's our solution to this question. For question 36, we're going to graph this system of inequalities, and then we're going to state the coordinates of a point that satisfies both. Now, the first thing I do with these questions is make sure that y is isolated. So when I look at the bottom one, this one's okay, but the top one, the y is not isolated. So what I would do here is I would write this on the side, and our goal is to solve for y, which we could do by adding 9 to both sides. And then that's going to give us, we would have 3y is less than or equal to 21. And then dividing both sides by 3 tells us y is less than or equal to 7. So now that we got the y's isolated for each inequality, just note that the less than or equal to tells us we're going to graph the one in pink with the solid line. But since we just have a less than here, this is going to be a dotted line when we actually get to graphing. Now, if you know how to graph these by hand, awesome. Otherwise, you could use the calculator to get a rough idea of what this will look like. Now, a nice little trick if we want to graph this system of inequalities, we could go to apps here, and we're going to go to number 7, inequals, and I'm going to press enter just to continue. And when we go here, what we could do is we could type in y is less than or equal to 7. And now to switch this to a less than or equal to, we could scroll over to the left and press enter. And now I'm going to keep looking until I get less than or equal to. First thing I'll do is switch this to pink so that it matches what I wrote on the actual good notes there. And now I'm going to switch this over to less than or equal to, and I'm going to press enter. So now I'm going to type in the next inequality, which was negative 2x minus 4. So we've got negative 2x and then minus 4. And this one I selected blue. So that's what I'm going to do over here. I'm going to scroll over until I get to the y2. And I'm going to switch this to less than. But first, let's switch it over to blue. So this one we're going to want so that it matches. And do they have a nice blue, or is it just navy here? There it is. So we have blue over here. And then I'm going to go over to the equals, and I'm going to scroll until I get less than and press enter. And now we press graph. And what you'll notice here is that we get the system of inequalities graphed out very nicely for us. Now, one thing to point out here, if you struggle to graph this by hand, you could press second graph and go to the table, and you could use these coordinates here to get you a good picture. So now I'm going to go ahead and graph both of these. Now, one thing I want to emphasize before moving on is that the pink line is solid and the blue line is dashed. And notice that we're shading underneath each of those lines. Now, for the last part of this question, we have to state the coordinates of a point that satisfies both inequalities. We have to justify our answer. So for this one, we could pick the point. Let's see. We have negative 1, 2, 3, 4. I'm going to go ahead and pick the point negative 4, 0. And justification here. So if I just state this point negative 4, 0, the justification is me showing that it's in the solution of both inequalities. But just to be safe here, I would go ahead and plug this point into both of the original inequalities. So we have 3y minus 9 is less than or equal to 12. So I'm going to go ahead and plug in. So this is our x and this is our y. We would have 3 times 0 minus 9 is less than or equal to 12. And then 3 times 0 cancels. And we have negative 9 is less than or equal to 12, which is a true statement. So this checks out for the first inequality. Now the second one is y is less than, and we have negative 2x minus 4. So now I'm going to plug in the x and the y. So we would have y, which is 0, is less than, and I'll go ahead and separate this. We have negative 2 times x is negative 4, and then we have minus 4. So this is going to give us 0 is less than, negative 2 times negative 4 is 8, and 8 minus 4 is going to simplify to 4 on the right side, and 0 is definitely less than 4. So this point checks out in both inequalities, so it's definitely a solution. So for question 37, Aiden and his sister Ella are having a race, and Aiden is running at a rate of 10 feet per second. Ella runs at a rate of 6 feet per second. And since Ella's younger, Aiden's going to let her have a 30-foot head start. And we need to write equations for both of them to model the distance they travel. So for this question here, what I'm imagining is we've got these two siblings racing. So Aiden's going to be over here. So there's Aiden. And his sister Ella, she's smaller, so she's going to get a head start. And the head start is going to be 30 feet. So thinking about this, we need to set up an equation, and it really helps to know this equation, that in general, distance traveled is equal to the rate times time. So this represents the rate, and this is the time traveled. But the only difference here is that we're going to use y to represent distance, and x represents time. So here we're going to say y equals, and the rate that Aiden is running is 10 feet per second. So we're going to say y equals 10x. So that's for Aiden. But now for Ella, we have to be careful. It's very tempting to just say y equals 6 times x and move on here. But the problem with this is not accounting for the fact that Ella has a 30-foot head start. So at time 0 here, well, first I'm going to write in our plus 30 to account for the 30-foot head start. But think about it. If we're at, let's say, time 0, x equals 0, then Aiden, in red, I'll write over here, would be y equals 10 times 0. Or he would have traveled 0 feet, while Ella, if we look, y would be equal to 6 times 0 plus 30. This tells us that Ella, in some sense, has already traveled a distance of 30 feet. So this accounts for her 30-foot head start. So now to graph this, notice we have this stuff from before still typed in here. Now, one thing, it's kind of a lazy fix. Just press second memory 712, and this is going to reset the calculator back to factory setting. So now I go to the y equals, and everything's back to normal. So what we have here is y equals 10x, and that I'm going to graph in the red spot so that it's consistent with what we had before. And then in blue, we have 6x plus 30. But now, when we go ahead and graph this, one thing you'll notice right away is that we really can't see a lot of what's happening. And that has everything to do with the fact that this graph goes up to 150. So I would first go to the window, and for one, I could change our x minimum to 0 because, once again, the graph is not going back in time. It's starting at time 0. So we're going to start at x equals 0, and I'm going to switch my y maximum to 150. That way, now when we press graph, you could see that we could actually have a clear picture of what's going on. But another thing here is that we could just keep scrolling along like this, but notice that when we actually go to graph this, the y-axis is counting by tens. So that would tell us that we only want to plot points that fall on a multiple of 10. So you see here at 0, this is fine because 30 is going to fall exactly on one of our squares, but then something like 36 is not going to be pleasant to graph. So it looks like here for the y1 column, what we have here, the 6x plus 30, that every fifth x value is going to give us a multiple of 10. So those are the ones I would care about the most. Now, one way around this, what we could do is we could press second window and we could switch from auto to ask. And this is going to allow us to just manually input whatever we want. So here I could just say, all right, what's going on at, I'll start at 0. What's going on at 0, 5, 10, 15. And if I need to type in one more, I can at x equals 20. And then these are the values I'm going to put on the graph. So now I'm just going to go ahead and graph these points. So now just go ahead and label these. We have y equals 10x, and this is representing Aiden. And then in blue, we have Ella, which Ella was y equals 6x plus 30. So this represents Ella. Now for the last part, we want to know exactly how many seconds does it take Aiden to catch up to Ella. So that would be at the point of intersection here, which is looking like about 7.5 here. So this we could do a few ways. For one, we could just set the equations equal to each other and solve this equation for x. So we're going to go minus 6x on both sides like this. And now this is going to cancel. We're going to have 4x's equal to 30. And if we divide both sides by 4, this tells us that x is equal to 7.5. So exactly how many seconds does it take? It's going to take 7.5 seconds. And the justification is the work that we just showed. Now, if we really want to be safe here, what we could do is we could press second trace number 5 for intersection. And we could go ahead and trace the intersection of these two curves. So what we have here, we're going to press enter before the point of intersection, and we're going to go after. Press enter a second time, third time, and you see here at x equals 7.5, y is equal to 75 for both of these, so our answer checks out.